Hi, we're going to, I'm sorry, this is 11.4, day 3, I think. I'll put it in the title for the file so you'll know what it is. We are converting not today coordinates, but equations. So yesterday where we were converting 3 comma 2 to something that's got an r and a theta, we're kind of going to do the same thing. It's just now going to be with equations. Polar equation is an equation where variables are r and theta, not x and y. And honestly, guys, to go from rectangular to polar, it's kind of like what you did yesterday, where you x does equal r cosine theta and y does equal r sine theta. But instead of knowing the r and knowing the theta, you're just basically going to use substitution. So in example 1a, I've got to convert x plus y equals 5. That is obviously a rectangular equation. I want to convert that to a polar equation. So I see this x right here, and I'm going to rewrite r cosine theta, okay? And then I'm going, and then I will add, here I've got r sine theta equals 5. And so basically, I mean, you got two more steps, I apologize, because you've actually done what you need to do as far as the substitution, and then all you're going to do is you're going to factor out an r. So you have r times cosine theta plus sine theta, equals 5, and then all you do is divide by this whole thing. You're going to divide both sides by this entire thing. So you're going to get r equals 5 divided by cosine theta plus sine theta. And that's really all you have to do. You want to plug in your r cosine theta for x and your r sine theta for y, and then you solve for r, is basically how you do all of these for converting from rectangular to polar. Now, that's obviously a pretty basic one, but that's the gist for all of them. All right, we are going to convert x minus 1 quantity squared plus y squared equals 1. I'm going to pause the recording and write a bunch of stuff, and hopefully it all works through the miracle of iPad and explain everything. We'll give it a shot. Let's see. Okay, so what I ended up doing, and I'll walk you through it. I just didn't want you to have to wait to hear me or to have me write it. So all I did was, obviously x minus 1 quantity squared, you FOIL that out, double distribution, multiply it out, however you want to say it. You get x squared minus 2x plus 1, you got your y squared plus or equals 1. Obviously, you subtract 1 from both sides. So then what I did was my x squared, remember x is r cosine theta. So it would have been r cosine theta quantity squared. And when that happens, you have r squared and cosine squared. Minus 2 times, instead of x, I wrote the r cosine theta. Plus, and then again, it would have been r sine theta quantity squared, but that would have been r squared sine squared. Then I took those two, wrote them next to each other, obviously, right? R squared cosine squared plus r squared sine squared minus 2r cosine theta. And then I've factored out the GCF from this pair right here, r squared times cosine squared plus sine squared. Now, if you remember from your identities, cosine squared plus sine squared, let me pick another color, there we go. Cosine squared plus sine squared is actually 1, right? That's a Pythagorean identity. So this is really just r squared minus 2r cosine theta equals 0. So then you factor out an r, so you've got r times the quantity r minus 2 cosine theta equals 0. So either r equals 0 or r minus 2 cosine theta equals 0. So then r equals 2 cosine theta. So that was a lot of work to get to one answer, but here's your one answer. Okay, and here's the thing. You can, if you want, you can write r equals 0, but this r equals 2 cosine theta actually covers this r equals 0. Because if it, let's say, for example, cosine was pi over 2, or I'm sorry, theta was pi over 2. When you do 2 times cosine of pi over 2, cosine of pi over 2 is 0, so 2 times 0 is 0. So this little mini equation right here is actually covered by the bigger equation. Okay, so that's all you really have to write. You can write them both and they're not wrong. All right, 3x, and I'm going to go a little bit faster. So I've got 3 times the quantity. Oops, sorry. 3 times the quantity, r cosine theta minus r sine theta, and I think I just switched those colors, but that's all right, equals a 6. Factor out the r, and so you have r times the quantity 3 cosine theta minus sine theta equals 6. And again, all you're going to do is divide by that lovely bit of mess in your parentheses. 3 cosine theta minus sine theta. Now, some of you will not be thinking, and you'll think, oh, I'm going to cancel. I'm going to reduce that, simplify down to 2 over 1. No, you can't do that. Please don't do that. Good grief, you're not allowed to do it. The reason you aren't allowed to do it is because you have a subtraction and you don't have a 3 with your sign. So please don't do that. Okay? Okay. Next one, I'm going to write it out, but I'm not going to give you everything, because here's what's going to end up happening. So we have x squared plus y squared plus 2y plus 1 equals a 1. Obviously, the ones are, subtracting both of them. Now, here's the deal, and you'll see this when we go to the next slide. X squared plus y squared, when I actually plug in like the r cosine theta and the r sine theta and I do all the algebra involved, that is just plain old r squared. So that's why I wrote it out in that first, 2 examples ago, because then you can actually see it. So that's r squared, plus 2 times r sine theta equals a 0. And so then, of course, you just factor out r again. So then you have r times the quantity r plus 2 sine theta equals 0. And so again, you have r equals 0 and r equals negative 2 sine theta. And no, I don't know why sometimes I write a small r and sometimes I write a capital R. And again, this r equals 0 is covered in the bigger equation. So you can just write that one if you want. All right, to convert from polar to rectangular, here's that lovely r squared equals x squared plus y squared, right? So that's basically, and I showed the algebra to prove that in example, 1B, like a few examples ago. X equals r cosine theta, y equals r sine theta, and tangent is y over x. These are all things that you kind of know and have seen. We're just applying them in polar equations to try to convert them to rectangular. All right, when you are converting polar to rectangular, you have types of equations, and so you have certain things you have to do every time you see a certain type. Anytime I see r equals a number, just plain old r equals a number, okay? What I'm gonna do is just square both sides, okay? If I square both sides, then I will get r squared equals 25. And r squared is the same thing as x squared plus y squared, and that equals 25. Guys, this is a circle with a radius of 5 and a center at 0, 0, which 2 of your examples previously on this day, like example 1B and 1D, I think, that's what we had. We had circles. Now, a lot of pre-calculus classes do conic sections, so your circles, your ellipses, hyperbolas, and they do the polar form of those at the same time. But because we're a Lakeland class and we have to I have to stick to 1650 versus 1700, that's why we don't do these back when we did conics, okay? But it is the same thing. It's just a polar representation of a circle. All right, so then the next type that you might see is you have an angle, theta equals an angle, obviously. Whoops. Okay, so anytime you have theta equals an angle, take the tangent of both sides. So tangent of theta equals the tangent of pi over 4. Oopsies, I don't know why I wrote y. Sorry about that. Pi over 4. All right, then using our substitution, tangent of theta is y over x, and that equals, guys, go to your unit circle go to pi over 4, find the tangent. Well, the tangent of pi over 4 is 1. Now all you have to do is multiply both sides. Oops, we'll just do it that way. Multiply both sides by x, so y equals x. That is actually just a straight line going diagonally through the origin. Okay. Okay, so this one is a little bit different. You have r equals a non-sine or cosine trig function, right? So what you're going to do is you are actually going to, anytime you see that, you're going to rewrite it in terms of sine and cosine. So it's really going to be 3 over sine, right? Because cosecant is 1 over sine. And then all you have to do is multiply both sides by sine. So that goes away. And you have r sine theta equals, 3. And remember, r sine theta is y, so y equals 3. There is your rectangular representation of that polar equation, and it is just a horizontal line. All right, this one's a little different. You've got r equals a number. You still have that number, but now you actually have a trig function. You have sine or cosine. So you can't, this is not like r equals a number. This is not like example 1a where you can just square both sides. So what you have to do is you have to multiply both sides by r. When you do that, you will get r squared on the left and you will get negative 6r cosine theta. Well, r squared is the same thing as x squared plus y squared, okay? And that equals negative 6 times, guys, r cosine theta is x. So when you do this, you've got x squared. I'm going to add 6x to both sides. So x squared plus 6x plus y squared equals a 0. The reason I left a little bit of space is because you have to complete the square. You're going to complete the square there. So you're only going to complete the square on x because it's got x squared and 6x. You don't have a singular y, so you're not going to complete the square on y. So remember, it's 6 divided by 2, square it. So that's 9 here, 9 there. And when I write this, it's x plus 3 quantity squared plus y squared equals 9. So that is another circle. The center is negative 3, 0. Your radius is 3. Guys, I'm only writing that little extra bit just to kind of, show you the connection between things that we've done before and things that we're doing now. You don't have to tell me that that's a circle and where the center is and the radius. Like, you don't have to say that. Okay, so we've got another one where we have theta equals an angle. So when we have that, you're going to take the tangent of both sides. Okay. Again, tangent of theta is y over x. And tangent of 3 pi over 4 is actually a negative 1. Okay. Now, guys, for these two examples, I picked nice angles, like pi, your pi over 4s, basically, where your tangent is 1. If it was something else, where, my y was a 1/2 and my x was a, radical 3 over 2, I would actually go and say, okay, 1/2 over radical 3 over 2, and that's what I would put right here, and I'd go through and simplify everything else the same way. But that's, you just go and take the tangent of whatever angle you have. Okay, oops, there we go. And so then we're just going to multiply both sides by x. So this is also a diagonal line going through my origin, but it has a negative slope, so it is falling from left to right. Okay, we've got r equals 10 sine theta, so I have to multiply both sides by r. I cannot square both sides. So I get r squared equals 10r sine theta. And so, of course, r squared is x squared plus y squared, equals 10 times r sine theta is y. So I've got x squared plus y squared minus 10y equals 0. Obviously, going to complete the square right there. And so I have x squared, should actually complete that, huh? That's a 25, right? And a 25 there, right? negative 10 divided by 2, and then square it. So we get x squared plus, oh, that's a terrible plus, sorry, y minus 5 quantity squared equals 25. And again, that is your actual answer. Yeah, I mean, it's a circle with a center at 0, 5 and a radius of 5. But you don't need that.